You might want to figure out exactly what GPU and driver combination you're running on, and they kind of fall into two sort of broad categories. One is so that you can make automatic selections in your app about quality performance trade-offs that you're going to make, doing things like figuring out which sizes of textures to use. If you're running on, some tiny little GPU that has 256 megs of VRAM, maybe don't try and use all those 4K by 4K cube maps. Also adjusting shader quality and various things along those lines. The goal is primarily so that you have a good set of default values for an out-of-the-box experience, so that when someone downloads and runs your game, that it will at least be reasonable on their system, and then they can go in and tune it themselves. The other set of reasons that you might want to detect what GPU and driver you're on is so that you can work around either hardware or software bugs. So one case of this would be, I know that Mozilla, for example, will detect and figure out drivers that have known security bugs, and will just blacklist those drivers. Okay, so kind of further going down why is, so here's a sample option setting screen from Crysis. There's about a dozen different things, and when someone first downloads and installs the game, if it runs slow because these values were set sort of wrong automatically, most people are going to look at that and be like, WTF. And not even know where to begin to start to adjust things so that they can actually be able to play the game at a reasonable frame rate. And this isn't even the craziest. So this is Shogun Total War, even more options, and in each of these drop-downs there's like 5 or 6 different things to select from. So the games themselves have a lot of different flexibility in how they configure their options, and power users can use that to tweak to make exactly the trade-offs they want, but power users are the exception, not the rule, and you want everyone to be able to just download your game and play and have it run. So there's sort of a couple different phases of detection that you can do. The first is just figuring out what GPU you're on. Currently, the only way to do this on Linux is to use libpci or something similar. There's a couple other libraries like this, but every distro ships with libpci to find the display controller device and then look up the vendor ID and the device ID. And then from that, you can have some sort of table in your app of, oh, it's this particular Radeon GPU use these default settings. It's this Intel GPU use these default settings, kind of thing like that. So I know that right now, Serious Sam for Linux on Steam uses this particular method, where they just have a giant table of every GPU that they've ever known.
Well, I guess to do that because DirectX gives you the PCI ID.
Right. There's some, yeah, and there's actually a few different ways on, and I'm going to get to some of that at the very end on other platforms how you can do this.
Actually, but this doesn't necessarily tell you that this is the device you're using.
Right. So yeah, and I'm going to get to that too. But yeah, so this does run into problems on, say, an Optimus system or something where, oh crap, there's 2 PCI devices that showed up as the display controller. Which one is the real one? Yeah, there is still some peril. And then detecting the driver, the classic look at the GL strings. This also is fraught a little bit with peril, just kind of like everything, in that the strings have. So really, only the GL version part of the version string has a defined format, and the rest of it is whatever they felt like putting in there. So looking at the 3 version strings there, all three of them contain information about the driver version, and all three of them convey that information in a different way. So talking to developers, what most people do, I talked to the guys at Valve about what they do on this, and they just look at these strings for some keywords. They look for Mesa, and NVIDIA, AMD, Intel. Just if those strings appear anywhere, then they make some assumptions from that. So memory detection is also kind of where it in some ways gets even worse. There's a set of extensions, one from AMD that they've had around for a long time, where you can query the available memory in a set of different memory pools. So the way that they advertise this information is sort of an artifact of how their internal memory management works inside the driver. That why you would have different reporting for textures versus render buffers, which are all going to live on card memory, I don't know why. And some of the information that it conveys is also a little bit weird. So it gives you back the information about how much total memory is in that pool, how much is free, or how much memory is free in that pool, what the largest block is, because they presumably have some sort of, block slicing. So you may have fragmentation. Yeah, thank you. I was blanking on the word. And then they also tell you about auxiliary memory, which I'm assuming is a holdover of like AGP card memory, which seems.
This extension has an undocumented
of course it does.
To the entire memory of the GPU.
Of course it does. Sweet. They're also using this in Serious Sam, and all they look at in this is the total texture-free memory, and just don't even bother querying any of the other stuff. That gives the most amount of information that you're going to get, and then use that to make the initial quality settings for texture sizes. So of course, if ATI has an extension, NVIDIA has to have an extension too. And theirs, of course, works completely differently and is an X extension, which nominally means it's an experimental extension, but they've been shipping it for quite some years. It's just not published in the official OpenGL registry, but it's available on their website, so it's not like it's completely hidden. And this gives actually some really nice information about the memory that's available in the system, and then at runtime you can make queries of it to find out if things have had to get dumped out of card memory. Although for the most part, if you ever get anything dumped out of card memory during a frame, you've lost. Your performance has already gone down the toilet, and you should have been able to figure that out because your frame rate is tanking. So there's a bunch of problems with all of this. Each vendor is providing different, so the thing that you'll notice is missing from this is Mesa doesn't provide any mechanism to get GPU memory. Until 6 months ago, nobody cared, and this wasn't even on our radar. And then all of a sudden, with Steam coming to Linux, everyone was like, how do we detect this stuff on Linux? I don't know. So all the strings are, it's completely the Wild West, and you may not even necessarily have driver version information in the strings. So figuring out driver versions, which is more an issue for working around bugs, is difficult. And everyone has a different extension for providing memory information, and they all provide completely different information. The other thing that's kind of irritating about this is that you actually have to create a GL context before you can figure any of this stuff out. Right? You can't figure out what you're going to run on until you're already running on it. And that's kind of frustrating, especially if your game has an external utility for doing configuration. So like Skyrim on the PC has, on Windows, pardon me, has an external app that it uses to set all the information, and then in game you can't really tweak anything, which is a holdover from it being primarily a console game where you get the settings that they picked for you on the console where you're running. And then having to troll through the PCI library is just... When they first told me that that's what they had to resort to, I actually apologized. Like, oh man, I am so sorry that you have to do that. That sounds like it sucks.
Do you know what we are doing in Wine? We are looking at the open shared version string, look at the extension, guess a probable PCI ID, and then have a database based on the PCI ID we guess, and then we are guessing memory based on that.
Wow, that sounds even more awful.
And we're doing it on OS X too.
It doesn't really work either.
What?
On macOS, we have a database for that one as well.
Right. Well, at least on Mac OS, there's like 10 video cards, so it's a lot easier. And so Apple has a different.
And we actually as well have a database where we have the marketing string for each of these GPUs, because some games look at that and depend on the correct marketing string from DirectX.
Right. So, and then in addition, you probably can't use this library, use this PCI probing method. If you have multiple GPUs, it's going to just fail. And it's probably, I don't think anything like this is available on Android, so you're just kind of sunk there. So on other platforms, things are a little bit better. Apple has a pretty nice interface called Describe Renderer, where they can advertise multiple different GL libraries, essentially, and then you can pick one. So you could pick the software renderer, or you could pick, if you've got a multi-GPU laptop, you can pick to use the integrated graphics or the discrete graphics. And then for each of those, as you're going through this, before you've made a GL context, you can make queries about what that particular device supports. So there's a query to find out how much texture memory is available. There's a bunch of queries to find out about what kinds of multi-sampling it can do and some things like that. And they also have a renderer ID, which isn't the PCI ID, but it's this kind of magic number, and they have this map of magic numbers to this kind of hardware. So there's like a value for GeForce 8 kind of GPUs, and there's a magic number for different generations of Radeons, or for different generations of Intel integrated graphics. So it's not the PCI ID, but it's probably enough information. And at least the game developers I've talked to are pretty happy with this interface on Mac OS. And if you really, really need the actual PCI ID, they do have a mechanism through IOKit to do the same kind of trolling around through the PCI bus information to get the more detailed data. So Windows also has a similar kind of mechanism called enum display devices that kind of gets the PCI information, but it gives you like a pile of strings. Yeah.
Actually, you can get it through DirectX as well.
Oh, okay.
DirectX.
Okay. Although, if you're writing a GL app, you're probably not. So the people that I had talked to who do GL apps on Windows, this is what they use to
but you actually run in Wine, we run into OpenGL applications that use Director or something.
Oh, okay. Okay.
You can also get it from the registry.
Right. Yeah. There's a bunch of stuff in the registry. And I think that you can probably also get the memory information through the registry. And then there's also the AMD and NVIDIA have those same GL extensions on Windows. So sometime this year, I I've been collecting feedback from developers, and I'd actually like to talk to you guys and get some feedback from you guys. So sometime in a Mesa release later this year, we're going to have some kind of extension to be able to provide this information back. It'll probably look something like the Apple interfaces, since that seems to be what people are mostly happy with. It won't be exactly that, because I think that there's some on a platform like Linux, where we have a lot more variety of hardware, there's some choices that they made in their interfaces that I don't think are appropriate. But it'll probably look something like that. So hopefully a bunch of this mess will get fixed, by this time next year. But in the meantime, this is what people are doing to actually ship games on Linux. Now that people are actually doing that. Any questions?
I have suggestions. At first I thought we were going to talk about performance counters.
Oh, yeah.
Would be interesting too.
Yeah. Oh, performance counters. I actually talked to Jesse back there.
Open source will be good.
Okay.
Unfortunately, but I'm working on it.
It's very difficult for NVIDIA too. We know how to read the information, but we don't know what it actually is. Whoops.
Ours, we have a whole programming architecture built into the chip, and we can read it. It's reconfigurable on the fly, so you can change it to collect all sorts of counters. It's ridiculously programmable. Yeah. Absurdly so.
I mean, basically all the stuff that you can do with CPU performance counters, they put all that kind of same kind of mechanism
I think
into the
it may be even worse.
Yeah.
It's even more
incredible.
But it's.
I mean, on the CPU you can like get interrupts and do additional sampling.
Right.
From these interrupts, kind of sound placed.
Right.
Call stacking them, and
it's really low level. It exposes a lot of internal implementation details of the silicon, and so they don't want to expose the whole thing.
Yeah,
so
right.
what we have to do is pick like kind of a subset and provides just some fixed programming for it.
Yeah, and it would be nice if it could be kind of cross hardware, but we'll have some problems with that. I mean, some of them, yes.
Yeah, I mean, well, even with CPU stuff, it's hard to do that. So
I mean,
CPU, has to sunset it.
having an indicator about memory usage, like bandwidth, the PCI bandwidth, memory bandwidth, and CPU or GPU shader usage. I mean, it's already good for games developers.
Useful stuff like bandwidth usage, cache rates, and
this kind of
stall times causes.
Yeah, but I mean, with the shaders, you could select the ultra setting if you see that even in the ultra setting, you're not using more than, I don't know, 80% of the shaders. No, the shader time.
Yeah, well, we're working on getting some of those things programming orders, and hopefully we'll get those.
And hopefully we can provide that too for NVIDIA. I'm sure we can.
Yeah, so we have to come up. There's an AMD extension for providing access to performance counters that they support. So we'd probably, and it's a fairly flexible interface. So we'd probably want to come up with some sort of
indicators.
Huh?
Indicators would be nice first.
Right.
And then the game could self-configure itself based on actual performance and not on
not
magic.
Not on, I looked up a number in the table.
Yeah.
Yeah, well, and it's the thing that we've tried to tell game developers, we being everyone who provides graphics drivers across all platforms, have been trying to tell game developers since ever is the only way to figure out what your performance is going to be on some random hardware platform is to run it. So run a couple sample frames while you're starting up, that maybe you don't even display, and then configure based on that. But nobody wants to do
some
that.
games do that.
Do they?
Yeah.
Really?
Yeah, well, they have to, because they do not even trust the extension string, so that's why I think Nero, the guys doing the video stuff, they are really rendering in an off-screen buffer and measure what they can really count on.
Right.
And that's the only thing to find out what they really can count on.
We ran across a game that rendered timed the first frame while we were combining shaders and shaders.
Right.
And then it took 10 seconds. Like,
yeah.
no, I'm not going to run on this.
Yeah. So, and that's kind of the problem, is that doing that has its own perils, which is, I suspect, why most games don't want to do that. They just want to. We figured it out when we were going through our validation, how to run on this hardware that we know, so we'll just bake that in and screw it.
Well, the thing is, benchmarking is hard if you've got a specially prepared setup that's nicely isolated.
Right.
Well,
it's hard to get deterministic results from.
Yeah, but I mean, they wouldn't have to be. You could still get results within a reasonable enough error bound.
You can distinguish between this is terrible and
right,
oh, maybe
right.
this isn't.
Yes, you could make kind of the fat thumb estimates of it's about that fast. Yeah. Any other questions? Yes.
The such a problem there in what of GPUs you actually got to use on these games.
I missed a part of that. Well,
the search problem where gets what proportion of GPU resources you can get of all of them available. If you're running on multi-seat configuration, for instance, it's a shared GPU, or it's a Windows application.
Yeah.
Problems.
Yeah, and then there's a flip kind of related problem of that, the case where you have like an SLI kind of configuration, where most of the detection mechanisms will tell you that you have a GPU of a particular kind when you really have 2 or 4 or something. So you've got the same kind of problem going both ways. You've got the problem where, yes, it says I have this super hot GPU, but I'm sharing it with 6 other displays. Or the other way of, it says I have this kind of mediocre GPU, but I've actually got 4 of them. So, and that's one of the things that a lot of the game developers that I've talked to have asked me about is, how are you going to advertise multi-GPU stuff? Because they want to be able to know when they're running in like an SLI kind of configuration. Because they have to do different things to be able to effectively use those. And when they asked me that, I said, "Oh yeah, I forgot those exist." Not many of those for Intel graphics.
On the other hand, on Intel graphics, we have kind of similar problem with thermal throttling.
Right.
An Ivy bridge on a desktop with like 100 watts TDP
Right.
is something completely different than
Yep.
an Ivy bridge with a 10 watt TDP where you can run the GPU for like 1 second and reload. It's slowing down to.
Yeah, I'm sure if Christian was in the room, he'd complain about the throttling on his MacBook there, on the
Well,
Air.
it's everything.
Yeah, but some are definitely worse than others, and the MacBook Airs are pretty bad.
Well, pretty much all that ultrabooks.
Yeah.
Actually, Chris figured out that with the multi-threaded software renderer thing in SMA, on desktop it makes stuff fast, and on mobiles it totally kills performance because the TDP, it goes over the TDP,
Right.
which causes the LLC clock to down clock to like 800 megahertz, so you have 0 memory bandwidth. So numbers go totally down.
So it's just normal clock or down clock? Yeah. No, nothing in between?
No, the thing is, on Ivy Bridge, there's 2 clock domains. One is for the GPU and one is for the LLC cache, the big cache, and the CPUs.
Yeah.
Yeah, so if you get too hot on the CPU cores because you're running multi-threaded, you also clock down the on-core, which totally kills memory bandwidth for the GPU.
Whoops.
Yeah.
Yeah.
It's not a perfect design.
Not yet.
The next one will be better.
Why did they build proper cooling into these laptops anyway?
Yeah. Well, I mean, and you'd have the same problem, with tablets, right?
For some reason, people don't want fans in those.
Yeah.
Loud. Why can't you build silent devices as well? Probably
literally
cool
it's
silent devices.
I think
Yeah.
part of the problem is the
We
is
just
the
we
actual
just need
silicon
magic,
is too
damn it.
small.
Well, I have one PDA from 1992. It says it's 0.05 watts. That one doesn't have any cooling problems.
Right.
What about performance? Doesn't have either.
Okay. I'm gonna go ahead and. Oh, and Intel's hiring, in case you didn't hear.